It's the Y in science!
Saturn, with its big bright rings, is one of the most iconic images associated with our solar system. First discovered in 1610 by Galileo, who thought they looked a little like ears, and later actually identified as a ring by Christian Huygens in 1655 through a more powerful telescope. This particular planetary feature has been the subject of much speculation and study. But on to the question, why are they there? The answer is actually very similar for all of the outer planets' rings, but today we will focus on Saturn. Thought to be made of debris from comets, asteroids, and/or moons, there actually isn't complete consensus on when and how Saturn's rings were formed. Maybe a comet got too close, or perhaps an icy moon got knocked off its path and into the planet. The prevailing idea used to be that the rings were about as old as the planet itself, around 4.5 billion years. Data collected from the Cassini-Huygens mission has changed that. Many scientists now believe that the rings formed within the last 100 million years. This would make Saturn's rings younger than many forms of life that have developed on Earth. Either way, one big reason for the existence of these rings is something called the Roche limit. The Roche limit is a way to describe mathematically just how close a satellite can approach a planet and still maintain its physical integrity. Basically, moons and other objects are perfectly fine outside of this limit. But if they cross this line, the planet's tidal forces will overcome their self-attraction and pull on them unevenly, tearing them apart. From here, the debris gets pulled into orbit around the planet, forming a ring system. But why did the debris form rings instead of falling into the planet? Well, pieces of Saturn's rings actually do fall into the planet, and quite often. But we'll get back to that. The debris formed a ring system instead of falling into the planet completely because of how quickly the particles are traveling. Each one of the billions of ring particles has its own separate orbit around the planet, and each of the rings travels separately at its own pace. They whirl around the planet faster than the speed of sound, the inner rings rotating more quickly than the outer rings, in accordance with Kepler's third law. All of the rings travel quickly enough to oppose the pull of Saturn's gravity and to maintain the ring system. However, in all their glory, Saturn's rings are not a permanent feature of the planet. Composed mostly of water ice, the particles get eroded and become smaller and smaller over time. From here, they can become electrically charged by ultraviolet rays from the sun, or by plasma clouds from meteoroid strikes. They interact with Saturn's magnetic field and get pulled into the planet by gravity, in the form of icy rain. Many scientists believe now that at this rate, Saturn's rings will only be around for another 100 million years or so. We are truly lucky to live at a time when we can see them, and we will continue to study their mysteries.